graphing quadratic functions, we have um, three different forms. Okay? First form you guys are used to, and that's standard form. I know this is kind of hard to read, it's dark. Y equals ax squared plus bx plus c. Okay, that's standard form. When we have an equation in standard form, to find the x value of the vertex, okay, now this is going to be a parabola, right? Quadratic equations are parabolas. And the vertex, let's see if I can go in a little more. Okay, so for the vertex, that vertex is that turning point at the bottom, or it could be the top, because our parabola could go like this, right? Hello. Thank you for the sticky note.
Oh, yeah.
Happy St. Patrick. Okay, so that's our vertex. To get the x value, remember that's a point, x, y, right? To get that x value, okay, because there's a line of symmetry, if you remember back from Algebra 1, there's a line of symmetry there at the x value of the vertex. So that's really important to find that x value. And it's, I know, again, I apologize for the darkness of the copy, but to find that x value or that line of symmetry, we use the equation x equals, and I got to write this over here. So to find the x value, we use x equals negative b over 2a. Okay, and that's, remember, when we have x equals a number, that makes a vertical line. And in our equation, it happens to be that vertical line for the axis of symmetry. Right? And it's got the step-by-step process here. Tell you how to do it. We're going to go ahead and substitute that value into the function to find the y value of the vertex. Okay, so in order for us to find the y value, we're going to take what we get for x, go back to our original equation, and then find the y value. Okay, it's kind of a pain, but then that will give us the y value. So that's step 2. Then you use your vertex as a point of symmetry, plot at least 2 additional points on the side to create the graph. In other words, you know, you're going to be using that T chart there. You have x and y. You're going to find the vertex, x comma y, and then you're going to find or choose 2 numbers. I usually use one lower and one more. I should say less, one less and one more to find my y's. In other words, if my point is 0, comma 0, one less would be -1, and one more would be 1. Then I plug those into the equation, I get my y's. All right, and then you can always use your calculator for these, but I'm telling you, by the time you go through all this and get all the information to plug into your calculator, it really, you know, by the time you get to this point for the data to put in your calculator, you can almost do it. It's actually easier to do it in your head. Okay, vertex form is the second form. Now, you're kind of used to this because it looks kind of like the absolute value general form, right? That's why we teach absolute value first. remember, in absolute value, you had y equals a times the absolute value, x minus h, absolute value, plus k, and the vertex was hk, where h is the opposite of the sign, k is the same as the sign. So when we do it for quadratics, instead of having absolute value bars, we have parentheses, okay? But remember, we got to have that squared, so we also add the squared parenthesis, x minus h squared plus k. And the first step is to find the vertex. Now, this is actually pretty easy for vertex form because, like I said, we could just read our HK or vertex right off the bat. You don't have to go through these um, algebraic expressions or equations to solve for x and y. We have a vertex right from the equation. So this is much easier than standard form. In fact, that's why there's a smiley face here. So you're going to use a vertex as a point of symmetry, plot the 2 points. So what you did here, you're going to have to do here, your HK, and get one less, one more, and then you got your 3 points to draw your parabola. You've actually skipped all of this algebra if it's in vertex form. Okay, again, you could always use your calculator. This one would actually, because it's in vertex form, this form is kind of pretty easy to put in your calculator and use your calculator for it. Okay. The last one, intercept form. Now, intercept form, in the past, I've kind of, I don't, I hate to say it, but I've almost ignored it. You can't even see that. Should I try a different color? I got one orange. Let's see if that works any better. A little better. Okay, so intercept form, I tell you the truth, haven't really focused on that in the past. However, um, it's it's really important if you go on in math. Okay, pre-calc, calc, they use this form an awful lot. Okay, um, what it is, it's like factored form. Okay, it, pretty much that's what it is. So to find the zeros, so it's in factored form. Remember, to find the zeros, when you did factoring, you set them equal to 0, and that's where it crosses the x axis, right? So that's fine. So you get your 2 points crossing the x axis, okay? That's these 2 points, the one less, one more. But you then have to, in step 2, you have to find the vertex. And then that has its own special formula, kind of like x equals negative b over 2a for standard form. Well, here, x equals p plus q, your 2 zeros, divided by 2. Then you have to go back, substitute it in for y, and that will give you the vertex. So it's as much, if not more work than the standard form. It's harder because you're not used to this form. We hardly ever use it. We teach it once when you're solving, when we factor things and we solve for the zeros of whatever equation, and then we don't ever use it again. And now they kind of really want us to emphasize this because so many more students are going on in math in high school. All right. It's kind of a pain to do in your calculator. We'll have to try it again. I'm not sure I'm not really calculator heavy because these two forms, by the time you get all the information, it's almost just as easy to continue on manually and do it from there. Okay. Three forms for graphing quadratic functions. Anybody have any questions on these three forms before we start doing some examples? All right, let's go on then. Uh, let's see, problem number one. We look at, it's in standard form, so we kind of don't really have to determine that because it says so. So we need to find the axis of symmetry first. Remember, the axis of symmetry for standard form is x, that's step one, by the way, x equals negative b over 2a. So here, I'm going to go ahead and put my a, b, and c up here. A equals 2, b equals, be careful here, it's a negative 4, I'm sorry. And c is a positive 3. So my vertex x equals negative b, so b is negative 4, over 2 times a, which is 2. So I have positive 4 over positive 4, so my x is 1. So here's my vertex, x is 1, x is 1. Now I have to find y. All right, so what I do is I take my equation. Wherever I see an x, 2, and I always put parentheses for my x's. Squared minus 4 parenthesis plus 3. I kind of squished that together too much. And my x is 1. So I'm going to go ahead and put my x in there. So 1, 1. Oh, I should have did it down here. So 1 squared is 1. 2 times 1 is 2. Minus 4 times 1 is 4. Plus 3. So my y, 2 minus 4 is negative 2. Plus 3 is positive 1. So there's my vertex. 1, 1. Now I'm going to choose one lower. So I'm going to choose 0, which is always a good one to choose, and one higher, 2. Then I'm supposed to go back and plug those in. So I have y equals 2 times 0 squared minus 4 times 0 plus 3. Well, these are going to zero out. So y is going to equal 3. Okay. And then the next one is I'm substituting in 2. So 2x squared is 2, because that's what I chose, minus 4, 2, plus 3. Okay. 2 squared is 4. 4 times 2 is 8. 2 times 4 is 8. So 8 minus 8, well, there's 0 plus 3. Lo and behold, these two should be exactly the same because it's one less and one more. All right, if you really trust yourself on one of these, then, obviously you don't have to do the other. All right, let's plot these and graph them. Vertex, 1, 1. 0, 3. And 2, 3. So here's my parabola. Oops, this should be a little more rounded. Okay, let's mention a couple things here. I told you that the axis of symmetry, that x equals negative b over 2. Well, when you get 1, that's my axis of symmetry here, x equal 1. Here's x equal 1. Well, here's my axis of symmetry. Remember, it's a vertical line at x equal 1. I could have found just one point. I could have found that 0, 3. And notice that that is 1 away from the axis of symmetry. 1 away from the other way is axis of symmetry. So I could have used that. Let's see. I knew that it was going to open up the transformations. All follow the same rules in these 3 forms. So I knew that my parabola was going to be opening up because of the positive 2. That's about all I can generalize from that. All right, so let's do one with the calculator. Let's see if it's any easier or any harder. So here's my calculator. I'm going to try and I'm going to scoot this out so you can see what buttons I'm hitting here. Okay. So we're graphing, right? This is the whole purpose of this. We're graphing functions, quadratic functions. So I'm going to go to my y equals button. And I'm going to put this equation in. Negative 1/2. Here's my negative sign. This, don't use minus sign. This is my negative. Remember, put all fractions in parentheses, just because we never know when it's going to screw things up. Okay, so negative 1/2 x squared. X squared. Okay. Plus x. So plus x plus 4. Plus 4. And I'm going to graph this. And if I'm lucky enough, it'll come up on my screen. Okay? Because I'm using a standard screen. I'm using my Zoom standard. Okay? That's kind of like my default. And it just so happens that my parabola fits on this. We're lucky. Many times we have to play with the windows to get our parabola to come up on our calculators. Remember, this is only going from negative 10 to 10, negative 10 to 10. If my parabola is down here somewhere, it's not going to show up. So, and that will happen with application problems. Might even be the next section. I can't remember. Okay, so there's my parabola. I'm going to go to my table here. Second graph. And this is the easiest way to see my vertex. Now this I'm going to zoom in. Okay. Remember, my vertex from this chart, these y's are the same. So if my parabola here, now, again, it all depends on my calculator. And this particular problem, we're going to see if we can get repeating y values around our vertex. It'd be nice to have whole numbers or even whole and a half. We can graph like 1.5, but when we started getting into 4.125 or something like that, it's going to be a little harder. But hopefully we'll find whole numbers around our vertex. So I'm looking at my calculator here, and I don't see a lot. Oh, I do see some repeating numbers. Okay. I see a 4 here and a 4 here, a 2.5 here, and a 2.5 here. So my vertex has to be 1, 4.5. My vertex has to be 1. My x value is 1, My y value is 4.5, 4.5, whatever you want to use. You want to use 4.5, that's fine. Okay, I'm going to get some numbers. I'm going to use one higher, which is 2, 4, and one lower, -2. Oh, I'm sorry. Yep, 0, 4. So I got my 3 points. I know my graph's going to be flipped or reflect because of that negative sign, -1/2. So here's my vertex, 1, comma, 4.5. So 1, 4.5. It's also my axis symmetry, right? 0, 4, and 2, 4. Now, my vertex was 1, comma, 4.5. Axis of symmetry was x equal 4.5. Oh, I'm sorry, x equal 1. That's the y value. Here's my axis of symmetry. Okay. The only thing is you got to be careful because some tests or quizzes will, when they're asking for this formula, sometimes they want that work shown. Okay, we didn't actually do that. We did it from the calculator. But with our tests, the way that they are this year, you could probably get away without doing the algebra. You can do it off of the calculator. Any questions? So that's standard form. Yeah, this is a long section. Graphing stuff always is. All right, let's do the next one. Vertex form. Now this is going to be a little easier because vertex form is actually the easiest of the 3 forms. Right? I can easily read the vertex off of the form, right? Vertex is h comma k. So my h here is, we don't have, is opposite the sign, so it's a +4. My k is the same sign, so it's a +3. 4, 3. Now, you could choose 3 and 5 and figure this out. I don't know if I'm going to try using, let's see, just to be different. I'm going to use 0. So that's 4 less. So I got to go 4 more. So I'm going to use 8. 0 and 8. I picked 0 because, oh, no, that doesn't really work, does it? Well, that's all right. No, it's not going to work because it's going to be off the graph. So I'll go back to choose my 3 and my 5. I was trying to be clever, but it's backfired. So I'm choosing 3 for my x, -4 squared plus 3. So I get -1 squared plus 3, which equals 4. I have 3, 4, and then I have to do the same thing for y. I'm sorry, for 5. So 5 -4 squared plus 3. Again, it's going to be 1 squared plus 3, or, hey, look at that, same number. So I got my 3 points. 4, 3 is my vertex. And then 3, 4. Bless you. And then 5, 4. Bless you.
Bless you.
You're welcome. There's my parabola. Axis of symmetry. X equal the x value of the vertex 4. We should plot that, point that out on our graph. Here's my axis of symmetry. Sometimes I may even say, hey, label it. Okay. And then we'll do, let's do a calculator version. So here's my equation. Y equals -2 x plus 3 squared plus 7. Graph it. Hopefully it's, yep, it's on our graph. We don't have to mess with the window. Let's see if we can find our vertex. Hopefully we can go to the chart and find it. Second graph. See if we can find any numbers y repeating, and we do. 5 repeats around this number, -3, 7. So that's our vertex. And then I have -4, 5, and then -2 and 5. By the way, if I can't easily find the vertex here, I could go back to my graph and use and try to calculate what it is. If I hit my second trace, this one's opening down, so I'm going to have a maximum. I would choose that, and it's asking me for my left bound. I got to be left of my vertex. Hit enter, right bound, get to the right of that vertex. Hit enter, and then hit enter again, and it gives me my vertex. Who's -3, 7, right here. -3, 7. Okay, let's plot it. -3, 7, -4, 5, -2, 5. Here's my parabola. Oops, I missed that point. Axis of symmetry is x equal -3. Highlight that axis of symmetry. Okay. And the last one, intercept form. All right. This, again, is one you're rarely going to see, but it does come up, especially if you want to know. Okay. So I have the equation y equals x plus 3 times x minus 5. So what you're supposed to do is set each one of these quantities equal to 0 and solve for x. Well, this one's fairly easy because we have whole numbers. We don't have a coefficient for x, so we're not going to have fractions. Well, you would subtract 3 from both sides. X equal to -3. Oh, that's our intercepts. And x equal +5. Right. Axis of symmetry. Now, if we go back is P plus Q over 2. So my P is going to equal, now it's got to be a minus, so it's opposite the sign. So it's -3, and my Q is, well, it's the same sign because it's already a minus. It's 5. You guys understand that? In our general equation, this has to be a minus. So it has to be -3. And our Q is +5. And also, that we already figured that out up there. Okay, so I got P -3 plus Q, which is 5, divided by 2, which I get 2 over 2, which is 1. So my vertex x coordinate is 1. We have to figure out what y is. Okay, y, well, we go back and substitute in x. So y equals x is 1 plus 3 times 1 minus 5, 4 times -4, or -16. Okay, so -16. So here's my vertex. 1 comma -16. 1 comma -16. Okay, then I have my 0, my intercepts, -3 and 5. So crosses my x-axis, -3 and 5. There's my parabola. Here's my x-intercept. Axis of symmetry, x equal -16. No, x equal 1. Do that a lot. Here's my axis of symmetry, x equal 1. X equal 1. Here's my vertex, and there's my graph. Now, somehow I think the calculator version is going to be easier. Let's give it a shot. Okay, go to my y equal. I'm going to put in 2 times, is that 2 or -2? Nope, +2. Times x minus 3 times x plus 1. Graph it. Hopefully it'll fit in my window. And it does. Okay, now this is actually a nice problem because it looks like my x-intercepts here cross my x-axis at a whole number. Okay, so I'm going to go to my chart, see if I can see that. Now, remember, let's go down here. There we go. Remember, these 2 points of the intercept, the y value is 0. So hopefully I have in my chart y numbers that are 0. Okay, and they are. So that y, it happens to be -1, 0. So that's an intercept. That's an x-intercept. X equal -1. And the other one's going to be x equal 3. And you can get that pretty easy off of here because setting those, it's because there's no coefficient for x. You know that x is going to equal 3 here, and you know that x is going to equal -1 here. Okay, So axis of symmetry, so there's my x-intercepts, -1 and 3. Axis of symmetry, x equal -1. Got that right this time. Here's my, um, no, that's not right. I got to do p plus q. P plus q divided by 2, 2 over 2 is positive. That's what I thought. So here's my axis of symmetry, x equal +1. Now all I have to do is find the y value of my vertex. Well, I could go back to my calculator here. Instead of plugging 1 back into the equation, I just look on my chart. My vertex, I know that my x is 1. So here's my x equal 1. My y value is -8. So the vertex is 1, -8. One, -8. So here's my parabola. So yes, the calculator was definitely easier for this problem. Now, if I didn't have any y zeros, y equals zeros, I would have gone back to my graph. If this graph like intercepted the x-axis in between dashes, I would have to do the second trace. I would have to find the zeros. 0, you got to be left bound, left of that point, hit enter, right of that point, enter, and enter again to get your 0. -1, 0, -1. Okay, and you would do the same thing for the other 0. All right, any questions? I know this is a lot of information. It's because we have 3 different forms of graphing a quadratic. Depends on what form. Again, I think the easiest form, and you probably agree, is that vertex form. Questions, comments, concerns? All right, guys, if you don't have any questions, have a good day. Otherwise, you could stick around and be more than happy to go over any questions that you have.